Hello, I welcome you all to this another interesting screencast. The problem reads, determine the equivalent resultant force of the distributed loading and its location measured from point A. Evaluate the integrals using a numerical method. This problem is coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. Alright, so we have been asked to evaluate this integral, and the actual problem that we are dealing with is to determine the equivalent force of this distributed load. So first things first, let me explain how we are going to sort out this particular problem. As always, we are using the resultant force in the y direction, that is to find the location. That is, at this particular point we'll have found the resultant force. For us to find the resultant force, we need to find the area under the load diagram, and we use a numerical technique to solve this particular integral, because it can take a little bit of time to solve this analytically, so we are better off using a numerical method. So we have the resultant force Fry times D, which will give us the location. So this resultant force times D gives us a moment which should be equal to the summation of moments about point A. And Fry is just going to be equal to the integral of the A, or the area under the load diagram, and summation of moment is just going to be equal to integral moment arm times dA, which is the resultant force. So basically these are the equations that we are going to use, then this will allow us to find their location. Alright, so this is basically what we need to do. So now let's now discuss about the numerical technique that we're going to use. There are several of them that you can use. For us, we're going to use the Simpsons rule. Okay, the Simpsons rule. And this rule says, given an integral, okay, from a to b, okay, of a given function, then this is approximately equal to delta x. Okay, delta x, this is the width. It's a width of the subdivision. So imagine we divide this particular area into a certain number of subdivisions. Let's say we divide it into 4. So we have this subdivision, we have this subdivision, we have this subdivision, and we have this subdivision. So each one of these subdivisions, they have the width of delta x, delta x, delta x, delta x. This is what it means. So the more the subdivision, the better the solution, right? It means the solution is slowly converging. It is slowly converging to the true solution. Okay. But of course, using hand calculation is almost difficult to do this. Alright. So you'll not be able to take a lot of subdivisions. Okay, and subdivisions are always defined by the letter n, which I will discuss about, which is always even. Alright, so this n is the one that gives us the width. Alright, I'll explain about that. So the more the subdivision, the better the solution. Alright, but for hand calculation, always your examiner will tell you how many subdivisions that you'll be required to use. Okay, because you not have all the time. Okay, great. So we have delta x, which is the width of the subdivision, divided by 3. Okay, all right, and then we have the first, okay, has no coefficient, is f of x0. Then the second one, you have the repetition of coefficients for x1. The second one, the third one, we have a 2. Okay, like so. And then so 4 and 2 keeps on repeating like that, depending on the number of subdivisions that you have. So if you have n equal to 4, okay, then you will have how many points? Okay, n equal to 4, these are the spaces in between. Okay, then you will have how many points? 1, 2, 3, 4, 5. These are the ones here. Okay, So the first one, uh, has no coefficient, and then the one that follows has a 4, then the third one a 2, then this keeps on repeating, it repeats, and then the last one will have no coefficient again. I'll just write it at xn like so. Okay, so this is our formula that we are going to use. It's not yet done, and delta x is just equal to the difference over these integration constants, right, divided by n. So it's b minus a. It's b minus a. What is happening to my... Okay, so it's b minus a divided by n, where n is just equal to the number of subdivisions. Okay, and they are always an even number. They are always even number. Okay, all right. So let's start working on the problem. First and foremost, of course, for us to define this integral, we need to get a small strip like we've always done. We need a small strip. Let's get a small strip there like so. This is a small strip. Oh, great. So there we go like so. There we go like so. Okay. So this is our dx. So now let's define our small areas. This height here is equal to y, which is equal to w. Therefore, our small area is just going to be equal to y, which is the height of this small strip or small rectangle, you can think of it like that, times dx, which is just equal to w dx. And we know what w is. So let's say let our w just be equal to the function of x. Therefore, our dA is equal to f of x dx. Okay, I'm just writing it like this because the whole function is quite long. I want to be using it when it's necessary. All right, so I'll say let our n for now, let our n be equal to 4. So 4 subdivisions, and therefore let our n, let me create a boundary here. So I'll say let our n be equal to 4. All right, and if this is the case, then we are going to say, and then we have a equal to 0 and we have b equal to 4, right? At the very end here, 3 plus 4. These are the integration constant. Since the length of our area is from 0 to 4, right? So we'll say integral from 0 to 4 of f of x dx. This is approximately equal to, okay, let's first find dx. So we said our dx is equal to, b, and we said b is a 4 and a is a 0 divided by a number of subdivisions are 4. Therefore, this gives us a 1. So if we are to draw this on the number line to just show, so this point here is 1. So we have 1, the other one, the other one, the other one, and the other one. So this point is, see, this point is this point is 0. Then this one here, 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 plus 1 is 3, and 3 plus 1 is 4. So these ones here, these differences are the delta x. Okay, that is delta x. All right, So having that, then we can write our function now, our whole expression. We have 0 to 4 of fx, which is this w dx, and this is approximately equal to delta x, and we said delta x is 1 divided by 3, and then we open bracket, we say f of x0, that is f of 0 where x is equal to 0 plus 4 f of 1, okay, where x is equal to 1 plus 2. Mind you, there are how many elements? There are 5 of them. F of 2 plus another 4. Like I said, 4 and 2 keeps on repeating. F of 3, and the last one has no coefficient, and the last one will have no coefficient, so we just write it as f of 4, and then we close. So now we are saying x0 is equal to 0, x1 is equal to 1, and so on and so forth, because we've chosen n equal to 4. If you had chosen n is equal to 6 or 8, then delta x could have been different, and then each particular value, also the elements could have had different values of x. Okay, so let's now do the calculation. So integrating from 0 to 4 of f of x approximately equal to, get your calculators. So the function is w, so we are feeding, so what we are doing is f of 0 is equal to, this is what we are saying, is equal to, this is what we are saying, 5 times 0 plus 16 plus 0 squared to the power half. So this is what we're doing. So this will give us how, what? So this gives us 16 root of 16, which is just a 4, and then again root of 4, which is 2. So this just gives us a 2. So here we put a 2. So this is how we are calculating. Is that fine? Great. All right, then let's move on. Where x is equal to 1, so we have a 4 here. We have a 4. What is the value where x is equal to 1? So this becomes a 16 plus 1 squared. Okay, so root of that, then plus 5 times 1, then root of that. So this becomes a 3.02. I'll just maintain 4 decimal places. 0204. All right, then plus 2, 16 plus 4, that's 2 squared is 4, root of that, then plus 5 by 2, that's a 10, then root of that. So we have a 3.8042. Okay, and then we have another plus a 4, 16 plus 9, root of that, plus 5 by 3, root of that. So we have a 4.472. Okay, 472, 4721. And then finally we have a 16 plus 16, okay, root of that, plus 20, root of that. So we have a 5.0653. So let's sum up everything. So what do we get? Dx, so we say 2 plus 4 times 3.0204 plus 2 by 3.8042 plus 4 times 4.7447474721 plus 5.0653 then divided by 3. So we have a 14, approximately a 14.88. Okay, so this is one case. And then the other case, so this, if you look at this, this is equivalent to delta, integral dA, okay, which is just equal to integral of the function dx, okay. So now we need to find the other part, which is the moment, and we know the moment, summation of moment about point A is just integral of the lever arm times dA, which is just equal to integral x f of x dx, okay. So this is the moment that we need to work on. Okay, so integral from 0 to 4 x f of x dx is just going to be equal to, not equal to, approximately equal to 1 over 3. Okay, so here we have x in front, so we have a 0, okay, then f of 0 like so, okay, then plus so we have 0 times f of 0, okay, plus we have 4, we have 1 times 4, 1 is x, times f of 1, okay, plus we have 2, and then times 2, and then f of 2, then plus we have 3, then 4, then f of 3, then finally we have 4 times f of 4. Okay, remember this? So we've already found these parts, these ones, we found these. Okay, right? Agree? We found this. So all we do is just replace now and multiply. We already have this value. So integral from 0 to 4 f of x dx approximately will be equal to 1 over 3. So this will just be equal to 0 times 2 plus 1 times 4 times 3.0204 plus 2 times 3.8042 plus 3 by 4 by 4.4721, okay, plus 4 by 5.0653. So this is what we have, and therefore, and this gives us a 101. This gives us a 101.2248 divided by 3. And then when we divide by 3, this gives us a 33.7416. All right. So we said FR dy times d is going to be equal to the summation of moments about point A. Okay. And our FRY d, so we have the summation of forces. Okay, let me move this the other side. So we said that FRY d times d is going to be equal to the summation of moments about point A. And Let's work out this. Summation of forces in the y positive going up. This is going to be equal to FRY, which is equal to a minus integral of the A, which is equal to a minus integral dA is just fx dx, which eventually is equal to minus 14.88. So this minus just indicates the direction of the force. Okay. Then we have summation of moments about point A, anti-clockwise being our reference. So this is a negative a clockwise integral of the lever arm times the A, which is equal to integral of x f of x dx, which eventually is approximately equal to a minus again just indicate the sign of the moment, 33.7416. Then d therefore is just going to be equal to the summation of moments about point A divided by FRY, which is just equal to 33.7416 divided by 14.88. A d therefore is just going to be equal to, let me just calculate. This gives us a 2.27. Okay, approximately that. 2.27 meters. Okay, 33.7416 divided by 14.88. 2.27 meters. Okay, so if we are to replace this, maybe it is somewhere there. Okay, let's say it is somewhere there. So this one is the resultant FRY, which is equal to 14.88 kilonewtons. And then this distance here, this lever arm, this lever arm or the position from measured from A okay, so this one here is equal to D is equal to this D is equal to, let me use red, so this D is equal to 2.27 meters. Okay, so let me just outline the final solutions. So we have D there. We found our D and we found our resultant force, which is equal to, where is it? This one here. Let me just write it. Okay, I can write it down here. So we found our resultant force, which is FRY equal to 14.88 kilonewtons. So let me just also outline it like so. Great. Again, if we had used more subdivisions, the approximate solution could have converged to the true, or the accuracy could have increased. We only used 4 subdivisions and we found an approximate solution of the resultant of 14.88 and the location being 2.27 meters. I hope the video was helpful, and if it was, give me a thumbs up, like my video, consider subscribing and liking my channel. Bye bye. See you in my next screencast.